Greetings everyone, this is Mr. Mullen. I'm doing a podcast today on the first part of naming chemical compounds, and we call this this branch of chemistry nomenclature. So we're going to give names to compounds so we can all speak the same language. So the first one we're going to talk about today is I'm going to show you how to turn a name into a formula for an ionic compound. So if I want to turn a name into a formula, and I would actually probably flip my paper to the side so I could fit all this on there, and I'm going to make a flow chart to kind of go through some examples and show you the rules. So write small and kind of fill your paper here, go all the way to the left-hand side. If I want to make a formula out of a compound's name, I'm going to look at, first off, what the compound contains. I need to figure out what kind of elements are involved. So if the compound in question starts with a metal or ammonium, remember, is NH4 plus 1. Okay, it's one of those weird polyatomic ions that's positive. So if it starts with either a metal, let's say it started with copper, it would start with Cu, or ammonium, and it has nonmetals in the compound, then it's going to be ionic. Remember, metals, nonmetals, transfer electrons, we have ionic compounds. So we have a special set of rules for naming ionic compounds. So that's what we're going to talk about today. So the first thing we need to do is we need to look at our substance, and we need to find the symbols and the charges of the compound. So the compound will always have two parts. It will have a cation and then an anion. Remember, cations are positive, anions are negative. So if I want to break this into two pieces, I need to find the symbols and the charges of those two pieces. So the cation is always going to be either the metal, or in some rare freaky circumstances, you'll have it be a polyatomic ion, and that would be NH4 is the only one it can be. Okay, so it could be a polyatomic ion. So I'm going to start with an example here. Let's say I have tin 4 sulfate. Okay. This is example number 1. I need to find the symbols and charges of the cation. The cation is always listed first. So there's my metal, tin. I know it's a metal. I look it up on the periodic table. I find its symbol is Sn. So it's not a polyatomic ion. It's not ammonium. So it must just be a regular metal. And I take off the periodic table, I find the symbol, it's Sn. Now I need the charge. So I'm going to look and find the group number, or if it has a Roman numeral, I'm going to use that. That Roman numeral stands for the charge that this metal atom is taking in this compound. So IV stands for 4. The charge on this is plus 4. So the symbol is Sn, the charge is plus 4. We've done the first step. Now we need to do the same exact thing for our anion, which is going to be this other piece. Okay, so the cation, the positive piece, is stuck to a negative piece, and they're bonded together, this electrostatic interaction called an ionic bond. So I look at sulfate, and I need to figure out what the symbol and charge of sulfate is. So either it's a single element by itself, just a nonmetal, which is gain electrons, or it could be a polyatomic ion. And if it's a polyatomic ion, I need to look at my polyatomic ion sheet to figure out what the symbol and charges are. So sulfate, turns out, is a polyatomic ion. A good clue is if it ends in ate or ite, it's always going to be a polyatomic ion. So you need to look at that sheet and try to find the one that you're looking for. So sulfate, I find it, I look it up on my table, it's SO4 minus 2. So now what I have to do is I have to, I've named it, I've given the symbols, I've given the charges. Now what we have to do is we need to figure out how many of each of these we need. We need to determine the subscripts by getting a net charge of 0. So what do I mean by this? So I right now have an excess of positive charge. This is not a neutral compound. It needs to be neutral. So this thing is going to go and find another one of these so that it can balance out. That positive 4 has to equal out to the sum of all these charges. Minus 4 is equal to 0. So I actually need not one but two SO4s. I like to make a visual sometimes when I'm doing this and kind of make a box. And the box just represents a neutral compound. So if I have twice the charge, plus 4, over here, then I need half the charge over here. I need 2 sulfates. So when I write this out, SN, I have one of them, so I'm not going to write any subscripts, and I have 2 sulfates, SO4, but I can't just put a 2 here because there's not 42 oxygen bonded to the S. I have 2 of those whole chunks, those whole pieces. I have 2 different polyatomic ions attached together. So my final answer is going to be SN parentheses SO4 2. This is my formula for tin 4 sulfate. I'm going to do another example with you. This is example B. Let's say I have a compound and its name is ammonium nitride. Ammonium nitride. Okay, so for ammonium nitride, we're going to start by finding the symbols and charges. So the very beginning, my cation is going to either be a metal or a polyatomic ion. Excuse me for a second. We're going to have either a metal or a polyatomic ion. I look at ammonium. It's not on my periodic table. It's one of those polyatomic ions. It's the only cation you're going to have. So my symbol is NH4, and that's a +1 charge. So I have symbols and charges of my cation. Done. Let's look at the anion, the second piece. Nitride. If you see this ending IDE, IDE is the way that we end nonmetals in compounds. Okay, so if I have a nonmetal ending, the ending of my name, so nitride is the end of this compound's name. If it ends in IDE, that's cluing you in that it's probably a nonmetal. Now there's some exceptions, but most of the time, if it ends in IDE, it's just going to be a regular old nonmetal. So what nonmetal starts with, what nonmetal ends in IDE and starts with nitra? Well, that's nitrogen. So this is nitrogen. I need to write the symbol, and I also need the charge of nitrogen. And to find the charge of nitrogen, I'm just going to look at the group number and subtract 8. So nitrogen is in group 5. Subtract the number 8, I get -3. That just tells me nitrogen needs 3 electrons to get an octet. Okay, so -3 charge. So I get these compounds together. We want to these ions together. We want to make a compound, and I look at the charges, and I notice that nitrogen has 3 times the charge. So 1 ammonium is not going to be enough. I'm going to need 3 of them. So if you want to do a visual thing, I'm going to show you a shortcut here in a second. You know, I draw this box. This represents a neutral compound. That nitrogen has a -3 charge. So if this is a +1, I'm not going to need 1. I'm not going to need 2. But I'm going to need 3 ammoniums. +1, NH4 +1. Now you don't have to draw this whole box, but this is just helpful visually. So I look at this to get +3. I have a +3 charge coming from the ammoniums and a -3 charge coming from the nitrogen, and that gives me a net charge of 0. So I know that I must have 3 ammoniums. So NH4, I'm going to put this in parentheses. Whenever I have more than one polyatomic ion, it needs to be in parentheses. I had 3 of them, and I had 1 nitrogen. Now nitrogen I do not need to put in parentheses. I do not need to put a 1 because there's only 1. Ammonium nitride. Now I'm going to show you a really fast shortcut. If you want to save some time, you don't want to draw this big old box. The shortcut is this. Take the charges of the cation and the charge of the anion, and I want you to cross off the charge, get rid of it, take the number, and make it the subscript of the opposite ion. So the 3 is going to become the subscript of my ammonium. The 1 is going to become the subscript of my nitrogen. I rewrite this as NH4, and I had 3 of them, and I had 1 nitrogen, but we do not need to write a 1, so I'm just going to erase that there. And there we go. There's our final answer. There's a shortcut way you can do it. Cross the subscripts. So this is how we go from name to formula, and I hope that this was helpful.